So here we are at problem 3K from the summer packet. We are asked to evaluate the limit as x approaches 0 of this particular expression. Now, if you go ahead and try directly, it's not going to quite work. You will get something weird on top over 0. Pretty much kind of like something that's undefined on top over 0. So that's not going to quite end up working out. Now, one thing though that you can do, if you think back to algebra, just to kind of make this entire top fraction a little bit more simplified and so that it's one fraction, we're going to try and combine these two fractions just on the top. So if like we're just imagining this thing above that blue one, that blue line, we're just trying to combine this fraction, the one on the left, with the one on the right. And how we do that is, if you think back in order to do that. So because this guy has 3x or 3 plus x, this guy has 3 minus x, the one on the left has to have that 3 minus x over 3 minus x. And pretty much all that is just doing that FFU technique that we've seen in the past. They're really, really close, but again, it's really just that simple sign that's a switch that makes them not exactly the same. On the right one, we're going to do the exact same by doing 3 plus x over 3 plus x. And again, the whole reason why we do that, if you think about it, 3 plus x divided by 3 plus x is the same thing as saying 1. So essentially, we are taking this guy, this is the one on the left, and multiplying it by that fancy form of 1. Okay. Same thing on the right. We're taking this entire right piece and multiplying it by a fancy form of saying 1. So we're not changing the actual expression. We're just going to be changing the way he looks is all. So on the right, on the left, we have 3 minus x times 1. Well, that's just still 3 minus x. On the bottom, I'm not actually going to go ahead and change anything, so we still have 3 minus x times 3 plus x. Big minus in between. And then on the right side, we have 1 times this 3 plus x on top. So that just comes out to be 3 plus x. And then again, on the bottom, we're just going to rewrite it. So we have 3 minus x times 3 plus x. And again, this is all over 1 big X. So again, just in that step, we just did a little bit of FFU. Now, the whole reason why we would do that is now that these have the exact same bottoms, we can go ahead and combine our tops. Just for, again, for that top piece of this fraction. Okay, so then we end up with the limit still, as x approaches 0, of combining like terms on top. We have 3 minus 3. Well, those end up just canceling out and giving us 0. You also have negative x minus positive x. So essentially, you have negative x minus really x. So that gives us negative 2x on top. On the bottom, we still have that 3 minus x times 3 plus x. And again, we still have that all over x on the bottom. So now at this point, we want to rewrite this guy. If you think about it, we now we really haven't changed anything because we still are considering this entire top fraction as one fraction, and really this entire bottom as its own fraction. And anything divided by 1 is still itself. So we really haven't changed anything. So we would do that. Negative 2x minus x times 3 plus x. And then instead of this individual division bar, I'm just going to division symbol. And then right after that, I still have x divided by 1, so x over 1. Now again, if you think back to algebra, anytime that you have a fraction, another fraction, you just end up with the reciprocal for the second piece, so that guy. So we still end up then with the limit as x approaches 0 of negative 2x over 3 minus x times 3 plus x. And then changing this to multiplication, and then doing the reciprocal for the second guy. So we have 1 over x. The reason why we would do that is canceling out. These x's will just... The biggest issue that we were having were the right here, because that would have given us a 0 on the bottom, and we can't have that. We can go ahead now and try, and we end up... Actually, we'll just... as x approaches 0 of negative 2 times 1 is just negative 2 on top over 3 minus x times 3 plus x. And now let's go ahead and use that direct evaluation 0 in. So when we do that, we end up with negative 2 over 3 minus 0 times 3 plus 0. And so that'll just end up coming out to be negative 2 over, looks like 3 minus 0 is 3, 3 plus 0 is 3, so 3 times 3 just comes out to be 9. And so that would end up coming out to be our limit. And these are all just equivalent to one another, so you can do the equal signs up. So again, that is problem 3K from the summer packet.